Today the topic is how our equipment and how our company can help you a little bit in reaching your CO2 targets. And one of the essential things there is first who we are, and that is a huge, I think, good point for going for FCT, because we are busy in different fields where the more or less the knowledge and the synergy between these fields can really help you a lot in your daily challenges. So I want to introduce you a little bit to our company, our story, and how we came to the products which we have today and how they can help you with selected applications. FCT ACTech is part of FCT International. Our big brother is the combustion product line, where you can get all the best burners for the various applications in cement and mining and other fields. And then there is a small brother, which is called FCT Flames. Maybe a company almost nobody will know from the name, but I'm very sure that you saw our products already, because we are also producing pyro shows. And for those which are my age or even older, they might remember in 2000 the Olympic Games in Sydney, where we had the opportunity to do all the fires there. And then the company I work for is ACTech, where we build the analyzers for you. And these analyzers, they are a little bit different, but I will come to the details a little bit later. Now, how are we spread on the globe? Our headquarters is in Adelaide, Australia, where we do the manufacturing and the R&D and the setup of the systems. And then we have representations in Europe. My combustion colleague is based in Vienna. I am based in the Netherlands. And then we have hubs in the western part of Americas and in Brazil. ACTech was founded in 1999, and the big difference of our analyzers with all the other ones is that we always deliver complete end-to-end solutions. Today we have 8 different products with various applications in the cement industry and also in mining and minerals processing. And I would like to go a little bit later to the details. And here is one selection of our customers that made together with us these products, because we are always on a learning curve, and we try to deliver really the things you need. So if we look back in the history, then our first online product, the COSMA Analyzer, was developed in a close cooperation between Adelaide Brighton Cement and CSI Rowe. And in 1999, we more or less formed the company and delivered the first professional XRD online instruments. And then fortunately, over the years, the technology developed, and we got the chance to improve the products. And since 2018, we came to a product range which is, I would say, for process and quality control, the state of the art that you can get today. And this is also one clear differentiation between our products and all the lab products. We focus on process and quality control. And it's very easy to understand that if you really monitor your process streams, you can easily improve the environmental impact, you minimize waste and rejects, you have a better quality, and this comes together with fuel and energy savings. If we look now to our first product, the COSMA Analyzers, it was a slightly bigger machine with a full XRD, with a multi-channel arc detector to cover the complete 2 theta range simultaneously. And over the years, we had a couple of installations where the cement industry utilized this technology. But of course, if you start in such a new field, not everything is super perfect. And we had the goal to produce an affordable, simple, easy to install machine that can give you as a cement producer the highest benefits. And I think we came really very close to the absolute perfect solution. And for this solution, we have to differentiate the specific needs in the process. And for that purpose, we came up with different machines. So if we look through the process, then at the first point is after the raw mill, where our RMX, which is an elemental analyzer, can help you a lot to reduce the standard deviation in the process of the LSF and the other modules to get a good control on the raw material. Here we look only on the XRF part, so the elemental analysis. Later in the process, we have the OFX, the FLX, and the CMX machine, which I will show you a little bit later the details about, where you get a combination of XRD and XRF to really have a good grip on your process. All the machines, they are super compact. So for your information, the size of this gray box with the blue bottom is about 80 by 60 by 50 centimeters. And the huge difference between a conventional lab analyzer and our equipment is that we do not prepare an individual sample. We connect our analyzer directly via this tube with a sampler. Of course, we can also do multiplexing to connect it to two samplers to switch between different sampling points. And the material is processed through the analyzer, analyzed in real time. And the material either can be collected for subsequent tests in the laboratory or automatically returned to the process. So it runs fully without human interactions. You might need about 15 to 20 minutes per week for a little bit cleaning and looking after the system, but it is not like the very complex installations of robotic laboratory or other equipment where you really need to have a champion next to it. It really runs fully unattended. And you get a result every 5 to 10 minutes, I would say, which can be directly fed into your process control software or your LIMS system, etc. The whole system is very compact. It's self-containing, so you don't need, besides electricity and maybe some helium for the light element performance, no other supplies. So you don't need external chillers or other media to run the system. And also the consumption is very economical, so it runs with less than 1 kilowatt hour. The machine can be put in a ruggedization kit to isolate it, that you have a constant temperature. So also the equipment does not require a laboratory container in the field. It can be simply placed next to the process as long as there is no direct sun or rain hitting the machine. Here you see one typical installation of our FLX, the free lime analyzer. All fine materials like raw meal, cement, etc. can be measured directly. In case of clinker, we use a primary crusher to reduce particle size, and we have an integrated mill inside to have a proper representation of the sample. So how does the measurement work inside? And I prepared for that purpose a short video.
In a far larger sample size to have a much better representation of what's happening in the kiln. In a far larger sample size to have a much better representation of what's happening in the kiln at any given moment.
So you see the material moves constantly through the analyzer. And this is also the big advantage of this technology. You don't have a static sample, you have a moving sample. If you compare it with a lab instrument, where usually the amount of powder in a press pellet is 10 grams, where you hardly will measure 1 gram of it, We process there per hour between 2 and 3 kilograms, where the majority is measured. So you have a gain of up to 50 times more material being measured, and therefore you have a much better information about your process. Now about the different applications, starting with the raw meal analyzer, which is only XRF analyzers, which is suitable to measure all the elements from sodium to uranium. And usually for the cement applications, we focus on silicon, iron, aluminium, calcium, sulfur, magnesium, but also other elements on demand can be discussed to be included. It is a constant measurement, so you get a result every approximately 5 minutes. We steer the sampler in a way that either we use a bypass system or we switch it on and off by looking at sensors that we have always fresh material in the analyzer. And the benefits are for you, I think, very obvious, that having a very low standard deviation in the feed of the kiln, you reduce the fuel cost, you need less energy, you avoid a lot of issues. It will have a very positive effect on wear and tear. Maybe, and this depends on the installation and your design of the plant, you need less homogenization. But you have also further down in the process a lot of advantages. For example, this can lead to a reduced energy consumption in the cement milling process by having a more consistent material. In the next step, more or less, we switch from the XRF to the XRD part. This is the free lime analyzer, which is usually positioned after the clinker crusher, after the sintering process, to see the free lime as an indication of the burning conditions in the kiln. And this analyzer uses only the XRD technology. For those that are not very familiar with the two different techniques, with XRF, you measure elements. With XRD, you measure mineral phases. One good example to illustrate it a little bit is if you take a piece of coal and a diamond and you do XRF, you will find out that both is built based on carbon. But if you look on the mineralogy, so the XRD signal, you see a different structure. And the structure is usually directly depending or predicting the properties of the material. Therefore, mainly after the kiln, you look more on the properties, and there XRD has a high added value. And the advantages are very similar to the RMX. So reduce energy consumption, have a more smooth process, and reduce the emissions. If you go later more down in the process, or also at that point, you can use the OFX, which is a mixed analyzer. It has 2 X-ray tubes and 2 detection systems to be able to measure the mineralogy and the chemistry. And this gives you the full picture of the composition of the materials, and you can really tune the process in a way that it's super efficient, but that it's also sharp at the target values, not to waste energy. But you guarantee at the same time that you are on spot and your customers get the materials they expect. And then the last system in the process, which I want to introduce to you today, is the CMX beta cement analyzer. It is a machine which is tuned for the analysis of the cement after the cement mill. It comes with a larger XRD capability, so it can measure, besides the free lime and the halide, it can also measure minerals of interest like gypsum and calcite, but it can also measure elements like chlorine. And with this combination, you have a very, very detailed look on your material, and you can tune all the parameters you would like to tune to have a perfect quality control of your final product. And this opens for you various possibilities. On the one hand, you can reduce the clinker factor, which directly leads into a reduction of the CO2 emission. But it can also be used more or less to add some other additions like bypass dust to the normal or expected limits so that you don't get an overshot of the chlorine, for example. You can also use it if you look on the process side, that this real-time instrument gives you very, very important information when to switch between different cement grades, that you do not more or less waste the expensive product in the wrong silo. Overall, by looking on all these parameters, it enables for you the possibility that you reduce the wear on all the heavy equipment by running a process more smooth. And of course, the new cements, in particular, the things we heard yesterday, the PVC cement with fly ash addition or composite cements with fly ash and slag, these type of analyzers are very mandatory to be sure that the quality you deliver is in the spec and you give your customers the things they would like to have. And last but not least, by controlling the cement in a much better way, this can also give you a hand in the process that you can ask a premium price for your product. So I hope with these couple of slides, I have shown the added value of our instruments, in particular to be more efficient, to reduce the CO2 emission, and to have a very good grip on all steps in the process. There are some more possibilities which I, for time reason, didn't want to include in the presentation, but please feel free to contact us or some of my colleagues that we can discuss where are the pain points in your process and where our equipment could help you a lot. So thank you very much for the attention, and I'm open for questions right now.